Okay, we're really making progress now. Let's go get that final piece of the puzzle. Let's go find out how much water we have. I forgot to fill in that number in my data table, but you're smart enough to put it. You probably already put it in there, didn't you? You probably said to yourself, that guy, he ain't putting a number. Yeah, okay, I'm all better now. I forgot. I saw that when I lifted the board up that I forgot to put that in. All right, so now we're all on the same page of music. Now let's remember what we have done. On a previous data table, we have grams of ethylene diamine, don't we? We have grams of nickel. We have grams of sulfate. So if I come back, you can check your data table to make sure that I'm on the level here. We have all three of these. We have 0.1062. This number is probably stored somewhere. This number and that number are the fairly recent numbers that are certainly stored in your calculator somewhere. So if I have all three of the four things that make my complex up, do you agree with me that I could easily add those up? So why don't you go ahead, recall the numbers and add them up. You get something like 0.2417 grams, and that is the amount of what? Ethylene diamine, nickel, and sulfate in my complex. But how does that help? Is it not true when I started this whole analysis process, I started with this much of my nickel complex that I weighed out? The nickel complex that I threw into the container had nickel, it had ethylene diamine, it had water, and it had sulfate, didn't it? All of those things were in this 0.309 grams of nickel ethylene diamine complex. I know how much that adds up to, right? So if my 0.309 grams, if 0.2417 of it is those three, then how do I get the last portion of water? You got it, right? I take this number that I weighed out initially. You got to be careful to use the correct numbers here. We see all the time people just going and getting a small number like that one and putting it in the calculation, and it will wreck everything down the line, and you wind up losing 50 points on a lab report because you're not careful on this step. Make sure that you get the number that you weighed out. In our case, the 0.309 grams. That's the nickel, En, water, sulfate complex, the nickel En complex. If I subtract from that 0.2417 grams, that's the nickel, En, and sulfate, you can quickly tell me that that's going to be how much water is in my complex. Go ahead and do it. Get me a number. Yeah. You wind up with what? This is actually the number that you wind up getting. Give it to me in the correct number of significant figures. Just for fun, the correct number of significant figures. What do we wind up with? We wind up with what? I get 3 decimal places, 4 decimal places, 0 point what? Isn't that right? 0.067. That would be a 3 decimal place number. The rules of addition and subtraction come into play here. Okay, so now I know how many grams of water I have in my complex, but do I want grams of water? Well, no, I really don't. I want what? I want moles. Do you see why we converted nickel, En, and sulfate all to grams? We did it for that step right there. So we could get grams of water in our complex. And once we have grams of water, it really is a cakewalk to get moles of water. Let's just do that together, right? It's not looking, that 7 isn't looking too good. That's a little bit better. You know what to do here, right? Grams of water, moles of water. 1 mole of any substance continues to be equal to molecular weight of that substance. You might even have the molecular weight of water memorized by now. It's 18.01528. 18.01528. And again, you can do this on one line, right? You put 1 mole of water slash 18, right? And in parentheses, you've seen that before. Okay, that's not hard to do. What did you get for moles of water? Did something like 0.003738369 show up on the display of the calculator? Yeah. Let's write it to the correct number of significant figures. Look like just 2 siggy figgies right here on this particular calculation. Whew. Now I have moles of water. Okay? All right, here's what we're going to do. We're going to go and we're going to list all 3 of the moles, all 4 of the moles that we have, all 4 of these moles up on another piece of paper from our data table. We should have all these numbers stored in our calculator, and then we're going to go the route of getting the empirical formula. All right, so empirical formulas, this was a short video. Let's go to empirical formula on the next video, and we'll finish this thing out strong.